6, and we're going to talk about inverse functions. So something that we've already learned before. A function is 1 to 1. If for every y goes to every x, and for every x goes to 1y. So we can see that kind of an Venn diagram kind of scenario. We have, this is maybe our, I label A and B. So 4 goes to 10, 3 goes to 7, 2 goes to 4. Everything in our domain has to go to one thing in our range, and our range has to receive one thing from our domain. All right. So this is 1 to 1. So that is 1 to 1. But here it's not 1 to 1 because I have two different x's going to one y. So normally that is something that looks like this. I have one x here and one x here, and they both go to same y. So normally that would be a function, but it's not a one-to-one function because it fails the horizontal line test. So vertical line test tells it if it's a function, but vertical and horizontal say it's one-to-one. So this is not one-to-one. So everything in my domain has to go some. So if I have some random number in my domain, say 3, then that's not 1 to 1 because 3 is not going anywhere. Okay, same thing here. If I have a number, say 3 in my range, and it's not being connected in anything, therefore it would not be 1 to 1. And we can look and see the graph here. This is where we have two y values that are the same, even though I have two different x's. So this is 1, and this would be x2, and I'm getting two different. This would be f of x1. And so my x's are different, but my y's are the same. So that would not be 1 to 1. So it fails the horizontal line test, not 1 to 1. All right. So here is the formal definition for 1 to 1. So if my x's are not equal, then my y's cannot be equal. So if my x's are not equal, then my y's cannot be equal. That's what basically this says. If my x's are not equal, then my y's cannot be equal. Or we're going to do the contrapositive of that. We are going to say, well, let's go ahead and let this f of x1 equal f of x2. So that's like, if this is not true, then this is not true, right? So we're going to let our f of x1 equal f of x2, so we're going to let our y's equal each other. So that's f of a equals f of b, and then we're going to go ahead and prove that x1 does equal x2. So basically what we're saying, if our y's are the same, then our x's have to be the same. Okay, so that's what we kind of do. Here's the first example, x cubed. So if I plug in, let's go ahead and do the second one because it's already there for you. So I plug in f of a and f of b. So that means my y's are the same, equals, and I go ahead and solve for a and b and make sure a and b are the same. So here, if I plug in my a, I would get a squared. If I plug in b, I would get b squared. And if I solve, it looks like, because I could just square root both sides, it looks like a would equal b, so it's 1 to 1. But whenever I square root, I get a plus or minus. And we can see that from the graph of an x squared, that it's actually not 1. It's a function, but it's not 1 to 1 because it fails the horizontal test. So this is not 1 to 1. So remember, when you square root, you have a plus or minus, because this could be positive a equals negative b, which would not be true. A doesn't equal b. Or it can be positive, which would be true. Or it can be positive negative b, or a negative a and a positive b, which would not be true. So that would not be 1 to 1. If we look at the x cubed, we plug in our a, we plug in our b. Here, when I take the cube root, the cube root, that's fine because the cube root of 8 is 2, and the cube root of negative 8 is negative 2. So whenever I cube root something, I just get that, whatever that cube root is, positive or negative. And here, same thing with b, I'll get b. So this is 1 to 1. So this one right here is 1 to 1, where x squared is not 1 to 1. All right, so let's talk about inverse functions. So normally inverse is going backwards. So we use the f inverse symbol, f inverse. And so I have my domain and I have my range. Well, with the inverse, my range becomes my domain, and my domain becomes my range. right? And you can see from here, from these things right here, here's my domain 4, 3, 2, 1, and it goes to these numbers. Coming backwards, my B's, my range, becomes my domain, and my domain becomes my range, my receiving. And so we can see that switch with inverses. Okay, so that's what inverses is, right? F inverse, not reciprocal, F inverse. So that's not raised to the -1, it's F inverse. F inverse, or the inverse of F. All right, so that might be a little bit familiar. Okay, so if we want to find the inverse of things, if I have these points, f of 1 equals 5, f of 3 equals 7, and f of 8 equals -10, can you find the inverse of 7? Can you find the f inverse of 5? Can you find the f inverse of 10? Well, they just switch, right? My domain becomes my range, so 3, because I'm just going backwards. Just going backwards. Just going backwards. Okay, so this is true. This is how you prove, right, that they're inverse functions. If I take one function inside another and I get x, and then I do the opposite, I take the other function and put it into the other one, and if it equals x, if they both equal x, then they're inverse functions. We did this back in pre-cal. All right, so if I take two functions, say 2x plus 1, and I take 1/2 x minus 1, and I plug in this equation in for x, and see if I get x, and then I plug in this equation in for this x, and I get x, then these are inverse functions. But you can tell by the first one, when I plug that in, that I won't get x, I'll get -1/2. So those wouldn't be, when I plug the red one in here into this one, I get -1/2. So that would not be true. Okay, so that's inverse functions. And if you can remember, this is basically how we do it. Basically, we can rewrite y as f of x if we need to. We can solve the equation for x, and then we can go ahead and write it in inverse notation. Switch x and y. Sometimes when I have an equation, say y equals 2x plus 1, and I want to find the inverse, I just solve this for x, right? So y minus 1 and divided by 2 equals x. And then I just switch my x's and y's. X minus 1 over 2 equals y, and then I switch that y to f inverse. So there's the inverse function of this one. Okay? All right. So here you can have a practice problem or whatever. Basically the same thing. You can switch f of x to y if you want to, or you can just start solving it. Basically, you're solving for x. So the cube root of f of x minus 2 equals x, and then just switch this to x, and switch this to f inverse of x. There you go. All right, well, how does that apply to calculus? Well, the calculus of an inverse function is looking at our function and see if it's one-to-one and continuous, so it has to be one-to-one and it has to be continuous. Then, if that's true, if our original function, just f of x, is one-to-one and continuous, then the inverse of that function, whatever it is, it will also be continuous. Okay, then if we have a function, say f, that is one-to-one and differentiable, meaning the derivative exists, we can find the derivative, then this is also true. This is the important part. The derivative of our inverse, so this is our inverse, and it's the derivative, at a value of a will equal this. We'll be just taking, so if I want to take the derivative of the inverse, I can just take the derivative of my original. Okay, so this is the derivative of my original, and plug in whatever my inverse is at a, and then 1 divided by that. So I'll give you some examples here how this kind of works. Okay, so we want to find the inverse at a, the derivative of the inverse function at a. Okay, so here we have our function, so we're going to take the derivative of that. So the derivative, we can switch that to f of x if we want to. F of x equals, then we can take the derivative of that. So the derivative of that is just 2x, okay? And then the inverse of that, because we have something that goes like this. The derivative of the original evaluated at the inverse, okay? So we do need to find the inverse. So we have our derivative part, okay? So then our equation is going to look like this, okay? But what's going to go in this x is the inverse at a, okay? So I need to find the inverse of this equation. So I want to find the inverse. Okay, so the inverse would be square root of x. F inverse equals inverse of x equals square root of x. And so this is x is actually going to be the inverse function, which is square root of x. So this becomes 1 over 2 over the square root of x. Now I can go ahead and plug in my a for this x, 1. And so I'm going to get 1/2. So inverse, the derivative of the inverse function at 1. And this is f inverse up here. It's a -1. It's f at 1 is 1/2. Okay, so this 1b is a little more complicated. So here I'm going to take the derivative of this. So f prime of x equals 2 minus sine x. Okay, and then I'm also going to find the inverse of this. Well, this inverse is super hard to find. So we can think about it a little bit differently. Okay, so we can look at when I plug in just a number into this, say like 0. So when I plug in 0 in for f, 0 here, that's a 0, which is nice. 0 here, I get a 1. So 0 plus 1 is 1. So I get 1. Well, what's the inverse of just that? Well, the inverse of that would be plugging in 1 and getting 0. So f inverse of plugging in 1 gets me 0. And that's what this is asking for, right? But it's asking for the derivative. So that means I can now use this formula. The derivative of f evaluated at an f inverse of my a. Okay. So now I can go ahead and plug in my function. So 1 over 2 minus sine x. And then what's going to go in for the x is my f inverse, which is right here, which equals 0. So that's going to be 0 right there. So I go 1, 2 minus sine of 0. Sine of 0 is still 0. So I get 1/2. So that equals 1/2. And most of those complicated ones like this are going to be asking you to find this. So just plug in. Try to go backwards. What do you have to plug in for your x in order to get a 1 out? And that number right there is going to be what you plug in right here. All right,